Alright, this video is about a specific kind of sequence called a recursive sequence and what we call factorials. Okay? Recursive sequence. It is a sequence of numbers where each consecutive term is defined by the previous term, which means it depends on what the previous term was. Alright? So you'll see a little different notation because you got to look at the number right before it before you can predict the next number. So for example, write the first 5 terms and the expression for the nth term if, so the first term is a 6, we know that. 2, 3, 4, 5, 5 terms. Okay, so they tell you the first term, it is a 6. Now to get to the second term, so 1 plus 1 would give me 2, right? I want the second term. So I take the first term, the one before it, and add 1. So I take a 7. To get to the third term, so that would be 2 plus 1, I go to the second term and add 1 to that. Well, that's 8. Fourth term, I'm going to go to the third term and add 1. That's 9. Fifth term, 5 plus 1 gives me the sixth term. I'm sorry, 4 plus 1 gives me the fifth term. I want the fifth term. So I have to take 4, the term before it, and add 1. So that would give me 10. So each consecutive term depended on the one prior to it. Okay, now, that's the first 5 terms part of the question. Now the next section says, find the expression for the nth term. Okay, remember a sub n equals something. Give me the equation. So let's just look at this. Common diff. Each of these I just added 1, right? Okay, so we said before that whatever is going on here, I can multiply it by n, so 1 times n. Then I look at, okay, if I do 1 times 1, I just get 1, but that's not my first term. What do I need to add or subtract to 1 to get to 6? Well, I need to add 5, so I add 5. And then check your work, see if that makes sense with the other list of terms. So if n is 2, 2 times 1 is 2, plus 5 would give me 7, it works. 3 times 1 is 3, plus the 5 gives me an 8. 4 times 1 is 4, plus 5 gives me 9. And then 5 plus 5 gives me 10. So this is my expression then for the sequence, given only this much information, right? Now, a factorial, easy stuff. A factorial is the product of a number multiplied by each number less than itself all the way down to 1. For instance, let's say I had 4 factorial. That factorial is written right as an exclamation mark, okay? What that means is 4 times 3 times 2 times 1. And I multiply it out, okay? 4 times 3 is 12, times 2, well, that's 24. So my 4 factorial is equal to 24. That's what a factorial does, all right? Bring this up because they show up in sequences, okay? So you need to know how to evaluate them. Now, there is a special case. 0 factorial is always a 1, all right? So just take my word for it. If it's 0 factorial, it's not 0, it's 1. So look at example 3. Write the first 5 terms. Begin with n equals 0. So 0, 1, 2, 3, 4. There are now 5 terms here. And here's the equation. A sub n equals 2 to the nth power over n factorial. So a sub 0 is going to be 2 to the 0 power over 0 factorial. Well, anything to the 0 power, if you recall, is just a 1. And 0 factorial is 1. So this is a 1. A sub 1. 2 to the first power over 1 factorial. 2 to the first power is just 2. Over 1 factorial, well, that's just 1. So the next term is 2. A sub 2. All right. Equation says 2 squared over 2 factorial. Well, 2 times 2, or 2 squared is 4. 2 factorial is 2 times 1, which is just a 2. Reduce that, and that's just 2. Interesting. Look at that. A sub 3. All right, 2 to the third power over 3 factorial. Well, 2 cubed is 8 over 3 times 2 times 1. Well, 3 times 2 is 6, so 8 over 6, and yes, you always reduce, so that would be 4/3. And then a sub 4. 2 to the fourth power over 4 factorial. 2 to the fourth power is 16 over, remember this is 4 times 3 times 2 times 1, so that's 16 over 24. Reduce them both by 4, No, I'm sorry, I can reduce them both by 8, so it's 2 over 3. So my first 5 terms are 1, 2, 2, 4/3, and 2/3. All right, there's my first 5 terms. All right, evaluating factorials. This is just a little mini lesson on factorials, how to evaluate them. They're really pretty simple to evaluate, okay? So write them out. Write out what it means. So 8 factorial, 8 times 7, 6 times 5 times 4 times 3 times 2 times 1. All right, yeah, that's tedious. And no, you don't want to multiply that out. Just hang on and watch what happens. List this out. 2 factorials, 2 times 1, times 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. What you should notice are a lot of things are repeated. All of this cancels with all of this, right? So if I multiply that out, I get 56 over 2, but I can divide that. When you divide it out, you get 28. There you go. Look at example 5. 16 factorial. I can do this. 16 times 15 times 14 all the way down, right? I could keep going, but I notice the denominator is 14 factorial. Don't these just cancel out? And I can just multiply 16 times 15. Sure enough, and it's that calculator and you get 240. That's all there is to evaluating factorials. It's really not that hard. Okay, for class, I want you to try this one. I want you to write the first 5 terms and the expression for the nth term if a sub 1 is 2 and the next terms are defined by 2 a sub k minus 3. All right, try it out and we'll see how you did.